This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Welcome to another episode of Design Safe Radio. I'm your host, Dan Zehner, and I am joined by Britt Raubenheimer, who's a senior scientist in applied ocean physics and engineering at Woods Hole Oceanographic Institution, and she is the principal investigator at the Nearshore Extreme Event Reconnaissance team. And so we don't have to say that over and over again. We're going to call that NEER from now on. So welcome, Britt. It's good to have you.
Hey, it's great to be here. Thank you for having me join you, Dan.
So for those who don't know who you are and what you're about, can you tell us a little bit about who you are and your research focus? Just give us a kind of 60-second overview of what you do.
So my research is focused on the land-ocean boundary, primarily studying ocean processes and the interactions with sediments and the morphology, and then also the groundwater. However, this coastal system right at the shoreline is affected by so many different processes and different disciplines. So it's linked with what the community actions are, with what kind of construction there might be or infrastructure. It's also linked with the inland waterways that bring fresh water out, or salt water gets into inland areas, interactions with the ecology, the geotechnical processes. So I collaborate with other people that have that type of expertise. And that's part of one of my real passions, is to understand the near shore, the coastal areas as the entire system.
Yeah, it's really amazing, and a great segue to our first question to talk about today. So today we talked about, in your research focus, how interested you are in these interactions between systems. And that seems to be the focus of what you are the principal investigator for, which is NEER, the Nearshore Extreme Event Reconnaissance Group. So what's the focus of NEER, and what are you all trying to accomplish?
So the vision of NEER is to improve the resilience of this near shore system by obtaining perishable observations during storms. And if you look at the image behind me, which is showing ocean waves coming up and inundating the dune, impacting structures along the coast, to understand these processes, it's important to include not just the oceanographic processes, the structural resilience, but also how that water is affecting the sediments, whether or not there's erosion along the shore, how it's behaving during the storm, how ecology might be affecting those processes. So our goal is to obtain these observations that are perishable. And I say perishable because the entire system is changed by this storm. If you just go after the storm, you don't really understand what the processes were during the storm. So to get perishable observations before the event, we want to do site surveys before the event comes, because it will get changed, as well as during the event and after the event, to try and understand and model the interactions between the community and the natural system processes, the built environment, and then also the societal responses and actions to this event. So I put a big emphasis there on the before event. And that's a little different than some of the other NSF-funded extreme events reconnaissance groups. And that's because you probably can look at a Google image and get an idea of what the structures were before the event. But it's really difficult to know the sand and ecology and the biology is changing so rapidly that we don't have very good before event images of that. So we are trying to get out before the event. And I also mentioned coastal storms. Our focus is actually on many extreme events, anything that would put a big change to the system. The focus on storms is partly because with our current atmospheric forecasting abilities, we can forecast the storm often, not always, but often far enough advance that we can get out there before to get those before event measurements. But there are other events that also might qualify into a near response. If there's an extreme flood, for instance, that's going to bring a lot of water out towards the coastal area, we would respond to that. Anything where we can get out before the event is our primary goal to try and do. And then I also mentioned a system. Another goal of NEER is because so many of these processes interact. We want to entrain a really broad community of scientists in different areas, in different disciplines. So we're working with atmospheric scientists, wind engineers, geotechnical engineers, structural engineers, coastal engineers, the natural system processes, the geoscientists as well, social scientists, to work together to understand these processes are related to each other. And that also includes the federal agencies and the communities who are being impacted by the processes. So our mission is to entrain a broad community and to coordinate interdisciplinary teams to respond to these events and then to obtain the perishable observations.
I really like that. Just that focus on especially this niche of what happens to the ecology and the bathymetry, the ramp up to the shoreline, the interaction of the shoreline and the built environment, because it changes so much. Even just a few days ahead of a storm, it's something that most people won't think about. So can you give us some examples of a NEER deployment? Like, what does a good NEER deployment look like?
So one of our early deployments in 2020, and this was during a lot of the COVID lockdown, so it was a little bit different than some others. But one of our early deployments was for Hurricane Laura, and then also for Hurricane Delta, which hit the same area of Louisiana about a month later. Wow. So 2 hurricanes hitting the same area. And prior to Laura, it was a relatively small group of researchers because of COVID lockdowns. But a small group of researchers went out and trained students from other universities and colleagues from other universities and went out to examine the impacts of the waves and surge and how they cause shoreline erosion and sediment transport and the impacts on the marshes, because that area is very low-lying with very extensive marshes. Not a lot of structures. There are some along the coast, but not a lot. But those marshes are really important for protecting the inland areas. Yeah. Trying to look at the impacts on the ecology and the sediment strength in the marshes and the dissipation of the marshes, the dissipation in the marshes cause of the waves and the surf. So how they protect the shoreline. So prior to Hurricane Laura, that team got some instrumentation from the NEER Rapid facility on drones with multispectral cameras, pressure gauges. They also brought their own instrumentation. We coordinated with the U.S. Geological Survey, and they deployed 2 transects of sensors in advance of the storm in between some of the U.S. Geological Survey rapid deployment gauges. One of those transects crossed a breakwater that was being constructed along the shoreline, and it went from the shore in the ocean across a breakwater into the marshes. Another was just 2 kilometers to the east of that, where the breakwater hadn't yet been built. And it crossed the natural shoreline in the same area. So very similar wave conditions and everything else. And one of the things they found by doing that, really cool study to be able to look at those processes and compare and contrast. And they found that there was, in this case, 4 or 5 meters of surge that crossed the area. So the breakwater ends up being a very small feature. And it didn't really affect the waves of the currents very much. It did have some effect on the erosion of the shoreline, but it didn't affect the waves and the current dissipation as it came ashore. One thing that they found, though, is that breakwater trapped the water on shore when the water was receding from the coast. So it kept the marshes inundated for much longer. And they saw afterwards the marshes in that area had totally turned brown.
Whoa.
So what we're learning from that is that there's unintended consequences of structures. The marshes do provide natural, nature-based defenses of the shoreline that are really important for inland areas.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show.
Thanks to our amazing sponsors, the National Science Foundation and the NEER Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor.
I'm your host and NEER Facility Scheduling and Operations Coordinator, Dan Zehner.
We'll see you in the next episode. Until then, stay resilient.